Hello, Martin Chavez here. I'm responsible for EKG interpretation. So I'm going to recap on some of the anatomy and physiology of the heart to help understand the EKG. Deoxygenated blood travels to the heart via the inferior and superior vena cava. It all pools here in the right atrium. When the right atrium contracts, it passes through the tricuspid valve, goes into the right ventricle. After the right ventricle contracts, it goes to the pulmonary artery, where it goes to the lungs. Pulmonary artery carries deoxygenated blood, goes to the lungs. Oxygen exchange happens, waste exchange happens. Then oxygenated blood travels back to the heart via the pulmonary veins. It's important to notice this because one of the few times oxygenated blood travels through veins. So it goes into the left atrium, passes the mitral valve or bicuspid valves, goes into the left ventricle contracts, goes into the aorta, and is dispersed throughout the body. This information here is going to help understand the EKG a little bit more, help me understand with the time. So I'm going to call this big box that consists of 5 cubes, both horizontal and vertically. So this cube is one single little square. It's 0.04 seconds, and this whole box made up of 25 cubes is 0.2 seconds. So 5 of these guys, 5 boxes, each 0.2 seconds, makes 1 whole second. So 5 of these guys makes 1 second. Okay, so because 0.2 times 5 equals 1. So 5 of these guys is 1 second. It just helped me grasp the time on the EKG. So just trying to simplify it. In a 6-second strip, there are 30 big boxes made up of many cubes within. So in the 6-second strip, there are going to be 30 of these huge boxes, right? They're not that huge. They're kind of tiny, actually. Okay, so there's going to be 30 of these in a 6-second strip. Here we're going to talk about the electrical activity of the heart. This is the heart. I drew the atria kind of small, the ventricles big, because that's how they are anatomically. The SA node starts here. It is here, sorry. It's a natural pacemaker of the heart, and it could have the heartbeat 60 through 100 beats per minute. The SA node then branches off to the AV node, which is the gatekeeper of the heart, and the AV node can have the heart pump at 60 to 40 beats per minute. Okay, left atria, right atria, left ventricle, right ventricle. So the electrical signal travels from the SA node to the AV node, from the AV node to the bundle of His, and then the left and the right bundles. Left and right bundles. And then after that, it goes to the Purkinje fibers. So the left and right bundle of His are able to pump the heart at 40 to 60 beats per minute. The Purkinje fibers also at 40 to 60 per minute. It's pretty slow. The atria and the ventricles need to contract in sync. So they contract one right after the other. So the atria contract, and the ventricles contract. They need to contract in sync in order to adequately perfuse the body with blood. Here is a normal EKG line. It's a P wave, QRS complex, and a T wave. This here is the isometric line. Okay. So just to help understand and get a better picture, the P wave here is when the atria contracts. That's systole, contraction. The QRS complex is the ventricular contraction. That's systole, contraction again. The T wave here indicates ventricular repolarization, diastole. So it's the ventricles are at rest. Okay. So a question I have is, when and where does the atria repolarize? Diastole. When do they rest? It is actually here, hidden in the QRS complex. Okay. So atria contract, ventricles contract, atria repolarize, ventricles repolarize. Okay, here are some numbers that are important, and some intervals as well. This here, from the start of the P wave to the start of the QRS complex, is your PR interval. Okay, so atria contraction to ventricular contraction. There's a QRS complex, ventricular contraction. QT interval, which is ventricular contraction to ventricular repolarization, the end of the T wave. Okay, the normal PR interval, the range is 0.12 to 0.20 seconds. I like to remember it as 5 cubes, which are the little tiny boxes, or less. So 5 or less cubes. Okay, this is a QRS complex. Normal range is less than 0.10 seconds. I like to think about it as less than 3 cubes. It's actually 2.5 cubes, but I say 3. Okay. As the QT interval, normal range is 0.36 to 0.44 seconds. QT interval here, ventricular contraction to ventricular repolarization. So in order to help read rhythms, we're going to have to memorize some numbers and some techniques, okay? The regularity is the QRX complex. Is the QRX complex regular or irregular? You may use an index card to see. I'll show that later. It's a good way to see if they're regular or irregular. So you must calculate the heart rate utilizing a 6-second strip and counting the QRS complexes within the 6-second time frame. Number of QRS complexes in 6-second strip times 10 will give you your approximate heart rate. It's not very accurate, but it gives you some parameters to work with. Number 2, observe the P wave, if any. So observe the P wave, if any, and its relation to the QRS complex. Notice the amount of P waves before each QRS. Notice the time from P wave to QRS. PR interval is less than or equal to 5 boxes. A prolonged PR interval could indicate a first-degree AV block. So here we see that the P and the R interval is normal, less than 5 boxes. I didn't put the boxes, but it's just there to indicate that. Here you see I drastically made it prolonged. The PR interval is prolonged. As you can see by the dotted lines over here, there's only a few. So it's delayed. It's greater than 5 boxes. So it's signaling from the atrium. Okay, sorry. Here's the picture of the heart to help you understand a little bit more. So what's happening is that the signal from the atria to the ventricles is delayed. So I put an X there. So the signal is delayed, which causes the prolonging of the P to the R. Okay. So here, like it says, it's the signals from the atria and the ventricles prolonged, delayed. So it ruins the sync between the atria and the ventricles, contracting one right after another. And a prolonged QRS interval may indicate a ventricular delay. So that would be this here. If this QRS is wider than normal, then it would indicate a ventricular delay. Alright, these are some other numbers we must memorize or be familiar with. A normal sinus rhythm is characterized by a regular rhythm, 60 to 100 beats per minute. A P wave is upright. The QRS is less than or equal to 3 cubes, which are the smallest cubes. Smallest squares, sorry. It's actually 2.5, but I just round up to 3. PR interval is less than or equal to 5 cubes. Sinus tachycardia is when the heart's beating fast. The rhythm is regular, 100 to 160 beats per minute. The P wave is upright. The QRS is less than or equal to 3 cubes, 2.5. PR interval is also less than or equal to 5 cubes. Sinus bradycardia is when the heart's beating slow. The rhythm is regular, less than 60 beats per minute is the rate. P wave is upright. PR interval is less than or equal to 5 cubes. QRS interval is less than or equal to 3 cubes, actually 2.5. An arrhythmia or dysrhythmia is an extra beat out of sync within normal rhythm. The rate is irregular. The proper term is actually dysrhythmia. A PVC, premature ventricular contraction, is an ectopic beat. Ectopic means it does not belong there. So it's just out of place, as indicated here. Ventricular fibrillation is chaotic and it needs to be shocked. So you can't really read it. There's no P wave. You can't make out a QRS complex. SVT, supraventricular tachycardia. It's irregular. It's a very fast rate and it's dangerous. 150 to 250, 160 to 250 beats per minute, and needs to be shocked too, because it can lead to an MI. Atrial flutter is indicated by saw teeth. There's no P wave. It could be regular or irregular. See, this can be kind of distinct by these jagged teeth here. Atrial fibrillation is no P wave, and star is a regular rate. Okay, so it's kind of indicated by this little squiggly line, and then the QRS. You might see a T wave, no P wave. Okay, these here are a little bit more confusing rhythms. First one's called the first degree AV block. PR interval is greater than 0.2 seconds. So it's greater than one big box, 5 cubes. Okay. PR is prolonged. So as you can see there, the PR is prolonged. We talked about this earlier. So it's greater than 0.20 seconds. Second degree AV block, type 1 and type 2. So type 1, second degree, type 1, also known as the wonky Bach, Mobitz 1. So I like to remember this by an analogy. The P wave is a school kid. They show up early the first day of school. They show up a little late the second. The third day a little later, until they are completely absent the fourth day. Okay, and this is referring to the P wave. So see, the P wave is there, it's early, a little bit later, and then it's just absent. It's not there anymore. Okay, so the QRS complex is standing alone. Now don't mix up the T waves for a P wave. Okay, it's P, QRS, T. This. Okay, don't mix this over here. There's no P wave. Second degree type 2, I like to remember is 2 equals trouble. Terrible 2s for kids. Easy way to remember it. Too many P's. T's trouble. Too many P's. Okay, per QRS. So look at 1P, 2P, QRS. 1P, 2P, QRS. Okay, it's pretty easy to remember. Third degree AV block, complete heart block. The easy way to remember this is the rate is slow. It's usually 20 to 40 beats per minute. PR intervals are different and unrelated. QRS is wide, and it can have extra P's as well. Okay, so here's an actual EKG, and I wanted to point something out real quick. These 3 little lines here, 1, 2, 3, indicate 6 seconds. Okay, so look for those 3 little lines whenever you have an EKG. That could be your 6-second strip right there. Okay, so those are the fundamentals for EKG interpretation. There's much more information out there. You can find many more websites you can research to find this information. Okay, thank you very much. Good luck in studying.